Hello, welcome. So it's a great pleasure to have my interview partner, Taylor Cassidy from University of Leeds here today. So thank you for having time to do this.
Absolutely, yeah, it's great to be here.
Yeah, so you are for me something like a rising star in the area. So you have had a stellar career, I think. And this is something we would like to talk about, as well as your motivation to enter this area and to your work. So maybe Taylor, just tell me a little bit about your path into academia
Sure.
and how you got to this.
Yeah, it's funny because it brings together how we met. So I was an undergraduate. I was actually an undergraduate education student. I really wanted to teach high school math in Alberta, Canada.
Oh.
So I did, yeah.
Okay.
So I did 3 years of pure education research, and in my third year, I ended up doing a research project which was very interesting in terms of numerical analysis, but it also introduced me to the idea of applied mathematics as a field and thinking about trying to answer important questions throughout the sciences using mathematical techniques or mathematical languages. And I ended up sitting in a weekly kind of math bio research meeting that Thomas had organized. And what I remember of the presentations is not so much what was presented, but more kind of the camaraderie and the quiz we did at the beginning of every week, the pub quiz to see who won the chocolates or something. But that was really my first experience thinking about trying to answer questions in biology and using mathematical models. And that was what set me along the path of thinking about doing mathematics or being a mathematician in general. So I ended up moving to McGill University in Montreal, where I did my PhD. And that was my first introduction to thinking about problems in oncology, so thinking about solid tumor dynamics.
So who was your supervisor now?
I did my PhD with Tony Humphreys at McGill. I started working with Mike Mackey, who has a lot of experience in mathematical biology. And then I ended up finishing my PhD with Morgan Craig and Tony as kind of co-supervisors. And Morgan's at the University of Montreal. So that's another fun part about being in Montreal is you get to bounce between universities.
But your PhD is officially McGill.
McGill,
Right?
that's right. Yeah. And then I did a 2-year postdoc at the Los Alamos National Laboratory, where I worked with Alan Perelson, thinking about chronic viral infections. So I did some modeling to support understanding a novel treatment for HIV, and some new sort of therapies for hepatitis B, so these 2 chronic infections. And interestingly enough, my entrance into viral dynamics modeling coincided with the COVID-19 pandemic, which was an interesting time, to say the least.
So about the COVID pandemic, right? I mean, in some sense, you were lucky that you were already kind of an expert in viral infections, so you could feel a little bit useful, I guess, right? To try to do some modeling there.
Yeah, I think the most useful thing I did, I think during the COVID-19 pandemic is one, I talked to a lot of maybe non-scientific people in my circle about how do you understand what we're saying about vaccination safety or vaccination efficacy, or trying to keep abreast of the emerging literature in terms of those questions. And I reviewed a lot of papers. I didn't actually write any SARS-CoV-2 modeling papers. And my thinking there is that I didn't need to add more noise to the signal, and I would be better used this kind of fledgling expertise is kind, but to try to tease out what was good and what was maybe not so good about.
There was so much information out there, and some was reliable and others wasn't.
Yeah.
It was very difficult to find your way through.
So that was kind of my contribution, and my thinking was to not add more noise, but rather try to amplify some signal.
And so after your postdoc in Los Alamos, you had some time at industry?
Yeah, so I had done an internship in industry during my graduate training, and I really enjoyed this opportunity to sit with experimentalists or clinicians and try to use the quantitative tools and languages that we develop as mathematicians to try to answer really important clinical questions. And it was this opportunity to kind of practice what I preached. So the reason why I love what I do is because we're trying to answer really important questions, and I had this opportunity to sit down and to do it, which was
and I think in industry at the end they want something which works, right? Not just theoretical, not like a lemma or something, but something that works.
Yeah,
it's a completely new challenge, I think.
And I think this idea of what the outcome is changes from, okay, have you written a nice paper, have you understood this data, to are you improving the lives of patients? And that's a very different and much more weighty kind of outcome to try to contribute to, but you get to do it in these larger teams with people with incredible expertise across a diversity of fields.
That was my impression too when I talked here at the Fields Institute with several people, also some from industry. They always talk about teamwork. There seems to be much larger teams than maybe in science.
Yeah,
right?
that was my experience as well.
Yeah, okay.
And it means that the skills that are valued are slightly different. Because in academia or in mathematical modeling, a lot of what is valued is your technical ability. And what I found working in industry is that the technical ability is important, but what's more important is how well do you collaborate, how well can you communicate, and can you take, this work that has really pushed you to your technical limits and communicate to someone who hasn't done math since calculus without losing them, and while still communicating both your results and the uncertainty that's around them.
Wow, yeah, okay.
Yeah.
Very cool. That makes it very interesting.
Yes, yeah. It was, every day was a bit of an adventure.
But then you didn't stay in industry.
No. So I missed interacting with students. So as I mentioned, I had always wanted to teach, and
your original vision,
yeah.
To work with students.
And even as a graduate student, mentoring undergraduate researchers or doing teaching, I had always really enjoyed the excitement and the fire that they bring to these questions. And I had been missing that during my postdoc and then also in industry. So just made the decision to try to come back to academia, and I've been lucky to be at the University of Leeds.
Fantastic!
I'll be 3 years next week. So, no, 2 years. Started my third year next week.
Starting third year next week. Okay,
yeah.
Awesome. So how do you like Leeds?
It's very nice. Yeah, right. It's been an adjustment to get used to the UK system, both in terms of the way that their undergraduates are focused. So we're at the University of Alberta, where I did my undergraduate. Yes, I focused in mathematics, but I had much more broad training. I took astrophysics courses. I had a minor in French literature, basically, which is not the case in the UK, where the students take almost exclusively mathematics courses, which means that they have a very specific and deep training. But that was an adjustment when I was trying to understand what the students are actually doing.
Yeah, I can imagine. But so are you then involved maybe to redesign programs or set up new programs?
Yeah, we're in the midst of curriculum redefined, which, so for anyone at the University of Leeds, that will be a buzzword that they know. And the idea there is to trying to update our curriculum and the way that we teach mathematics students to be more in line with the revolution that we've seen in our field in terms of not just big data and machine learning and AI, but understanding how you can use computational approaches to complement pen and paper kind of classical mathematics tools that has been taught for the last 100 years.
Right, yeah. But science is developing, so math has to develop as well. Right?
Yeah.
I agree. Let's come to cancer modeling. So what got you interested in cancer modeling then?
I think for me, it started as a space where you have incredible questions that I think are really amenable to the language we use to describe dynamical systems. So thinking about time dynamics and thinking about, do you have eventual tumor growth, or do you have relapse or response? And for me, the idea of using mathematical language, so thinking about separatrices or attractors, or what can you do to perturb systems into the right basins of attraction, I think is the type of language that can really answer some of these hard questions, both in preclinical or clinical data. So for me, it was an opportunity to try to take this language that I had been learning through my academic training and try to answer some really important and interesting questions that seemed primed to be spoken about in that language or within that framework.
Yeah. And if I follow your career, you have been very successful in talking to experimentalists or clinicians, right?
Yeah.
So do you have new connections in Leeds, which you made?
Yeah. Yes, some new connections in Leeds. I have some ongoing collaborations from my time as a postdoc with clinicians in pharmaceutical companies working in chronic infections, which has been really nice. And again, I think, strangely enough, the most important part of my training has been this idea of how do you communicate with these people and how do you speak their language, because we're coming and we're asking them to trust us and to trust our results. And I think it's important to show up and speak on their terms, even though even though I'd love to talk about all the math I've gotten to do, it's really, can we answer questions that are important to them?
Yeah.
So it's been an exercise in kind of building collaborations and trying to show the utility of our work and the utility of our perspectives to answer these really important questions. And I'm lucky, so I'm in the math department at the University of Leeds, but they're very supportive of this interdisciplinary work.
Oh, that's very good.
Yeah.
So do you have like a cancer hospital in Leeds or something?
We do have a cancer hospital in Leeds. We have 2 major hospitals, so I might not do this quite justice, but it has a large catchment area of patients who would come to seek treatment in Leeds.
Okay.
And both these hospitals are associated with the university, which means that we have clinician scientists kind of on staff. And there's an established mathematical biology group at the university that I've gotten to kind of slot in with, which has been nice. And they've done some very nice work thinking about aerosol transmissions in the context of SARS-CoV-2, and that's been collaborations between the math bio group, but then also civil engineering and faculty of medicine. So yeah, we have obviously more collaborations and connections to build, but we're not starting from zero.
Fantastic.
At the very least.
Oh, that's really good. Yeah, no, this is really nice. Yeah. So then maybe as a last question about young researchers entering the area. So would you have advice for them? Should they focus on math? Should they focus on data analysis? Should they focus on cancer research? What would you suggest?
Oh, how long do you have?
Right?
My take is that ultimately I'm trying to train scientists, and I'm trying to train people who have a quantitative toolbox that they use to answer questions. And that means that much of their research and much of the tools that they develop are going to be question driven. And so what I'm looking for and what I would love to see people develop is, 1, their curiosity, but 2, their passion, and this idea that they're excited to learn something new every day. And one of the things I love about math bio is that you get to use new techniques and you get to learn new things, and you get to work from a problem specific point of view. You sit down, you want to understand the system, biological system, and to do that you're going to use your quantitative perspectives, but you're going to learn a whole bunch of new tools along the way, and you're going to talk to people. And I think you can't fake kind of that passion, you can't fake that excitement, and at the very least it means that when you talk to collaborators, I think they can feel it. And I think that's, what advice would I give people who are entering into the field is, be curious, don't be afraid to get excited, and kind of lean into the fact that you get to answer really important questions, and that's incredibly exciting. And I think that it should be exciting for students and postdocs.
Very good. Yeah.
I'll leave that there.
Leave it there. No, very good. Okay, that's awesome. Yeah, Tyler, thank you very much for your time. I think this was a fantastic interview.
I hope so. Yeah.
Covered a lot of ground.
Yeah, thank you for having me. It's been really nice.